In this video, we're looking again at using this nice formula that we learned in class that allowed us to find the derivative of the inverse of a function. Turns out the derivative of the inverse of a function is 1 over the derivative of the function itself evaluated at the inverse of the function. Alright, so we are going to use this formula again in this video. And I'll tell you right now, so that you do watch the entire video. At the end of this video, I will be giving you a few problems that I expect you to do. Okay, so first, let's begin. In this example, I'm actually going to give you a table. Here is the table. We have a table of values, one row of x values and a row of f of x values. When x is 0, f of x is -2. When x is 3, f of x is 4. When x is 6, f of x is 8. When x is 9, f of x is 15. When x is 12, f of x is 9. And when x is 15, f of x is 6. Here, that is the table, and what we'll be doing with this table. What we'll be doing is we will be trying to estimate. The best you can do when given a table really is usually to just estimate. Let's estimate d dx of the inverse function of f evaluated at x equals 8. Okay, so we are just trying to estimate, and we'll talk about what does that mean and how do we do that using this table in just a moment. But let's use this nice formula. Alright, so what are the things we'll need to know? First of all, we'll have to know what is the inverse function of f evaluated at 8, and also we'll have to determine, or at least estimate, a derivative for the original function. Now make sure you are clear. The table is giving me information about f of x, but the question is about the derivative of the inverse function of f of x. Alright, so first of all, let's see if we can figure out what is the inverse of f evaluated at 8. Well, let's see here. I don't know exactly what that is as of this moment. But what if I sort of take my cue from the last video and I just apply f to both sides of this? So f of f inverse of 8 is equal to f of x. Well, f of f inverse, they undo each other, so this is saying that 8 equals f of x. So if I look in my row of f of x, right there is where 8 equals f of x. What is the value of x that gives that? Oh, that's 6. Okay, so I now know that f inverse of 8 equals 6. Can you see? That is really what it's telling us when we look at this table. It's saying what value of x would cause me to end up with 8. So we reverse that, take the inverse of that. That means f inverse of 8 gives me 6. So that's going to be important and very useful. Now we need to try to estimate. We have to try to estimate then can we find the derivative of f at 6? Well, since we have a table, the best we can do is to estimate, but this is approximately the change in the f over the change in the x. This is really an average rate of change centered on this value x equals 6. And so you see we have some values of x on both sides. We have some values of f of x on both sides. I'm actually going to use these values on both sides to find this difference quotient. Right? So what is the change in the f? That's centered on 6 like this. So the change in the f is actually, if you look here, it's 15 minus 4. So we have 15 minus 4 over the change in the x, centered on x equals 6. So that's 9 minus 3. 9 minus 3. So 15 minus 4 is 11, and 9 minus 3 is 6. So this is what approximately, this is the derivative of f evaluated at 6 is approximately 11 over 6. We can estimate that to be 11 over 6. What should we do with this? Well, this was not the goal. The goal was not to find the derivative of f at 6. Actually, the goal is to find the derivative of the inverse function evaluated at x equals 8, and now we have everything we need. Using the formula, we can say this is 1 over the derivative of f evaluated at its inverse. Turns out that's the derivative of f evaluated at 6, which we just found was 11 over 6. And so this is 1 over multiplied by the reciprocal. So this is 6, approximately 6 over 11. So there is our answer. I'll just take a moment to point out, since this derivative is positive, it means that we expect that the function is increasing when we're near to the point x equals 6. Okay, so there was our example, and I'm going to now give you a few problems to practice with on your own. One of them will be just like the one I've done here, and the other two will be more like the first video. Okay, so do these problems. You will be expected to have completed these problems. So I'm going to give you another table. Here's a table. So here are my x values. Here are some f of x values. When x is 7, f of x is 12. When x is 8, f of x is 16. When x is 9, f of x is 11. When x is 10, f of x is 13. When x is 11, f of x is 7. And when x is 12, f of x is 4. Use this table to estimate the derivative of the inverse of f of x evaluated at x equals 11. So there's the first of the additional problems. The second of the additional problems, I'm going to give you that f of x equals x squared times e to the 2x. I want you to find the derivative of the inverse of f of x evaluated at x equals 3. And finally, for now, the third additional problem. Let's let f of x equal x plus the natural log of x squared plus 1. I want you to find the derivative of the inverse of f of x evaluated at x equals 3. So let's see if I can put these all here where you can see them. I'll pause on this for a while so that you can copy these down. There was also an additional problem in the previous video on this topic. Make sure that you do it as well. There may be a quiz which may contain problems like this or these problems. Make sure that you do these problems for practice.